Hello, good to see you again. Welcome to Block 5, Fraction, Decimal, and Percentage Equivalence, Lesson 12. I'll share my screen. So, in your previous lesson, you learned how to represent fractions on number lines. In today's lesson, you're going to learn how to identify and use simple equivalent fractions. I want you to pay very close attention to this lesson because it's going to help you in future lessons when you start to work with fractions. So the skill you're going to learn in today's lesson will become useful when you start to learn how to simplify fractions, how to add fractions, how to divide fractions. So you'll be able to quickly spot equivalent fractions and know exactly what to do. But before we start, I want to ask you for a favor. Please share the videos if to those you think can benefit. Like the videos and subscribe to the channel so that you can support and help our mission grow, which is to educate the global population of children who may not be able to afford private tuition. Thank you. In today's lesson, before we start, I would like you to do these retrieval practice questions. You can pause the video and answer the questions in 3 minutes. You can take longer, you can work at your own pace. You don't have to finish it in 3 minutes. Okay, assuming you've paused the video and you've worked through the questions, here are the answers. Let's discuss them. In the first question, you were asked to state the fraction shaded in each diagram. So you can see here that the circle is divided into 8 parts. So that's the denominator. And we have 7 parts shaded. So this shows 7/8. Here we have 12 squares, or I'll call them rectangle. They're not exactly squares, but we have 5 shaded, although they are scattered about, but we can simply count them. So we have 5/12. Here we have this rectangle here, or this block diagram or bar model, split into 4 equal parts. 2 parts are shaded, so this is 2/4. Now, you may have spotted that if we look at this diagram, we've actually shaded half of this block. So if we were to ignore the little blocks, we can see that we've shaded a half. So actually, 2/4 is the same thing as a half. Next, we were asked to shade in 100 square for each fraction, then complete the statement using the less than symbol, greater than symbol, or equal sign. 3/10 means you need to shade 3 columns, each column comprising 10 squares, and then 30 hundredths means you need to shade 30 small boxes, which happens to be exactly the same as the diagram we have on the left hand side. So in this case, we'll use the equal symbol. Let's do some new learning. Before we start, I want you to take a look at this diagram carefully. What do you notice? Well, we see that the diagram is split into 5 equal parts. So we can say that this is 4/5. What if we add another bar model at the bottom and then we split the bar like this? What fraction would you say is shaded? Well, I'm sure you would say it is 8/10, yeah? Because they're exactly the same size. The bar is the same length, and the parts that have been shaded, they are also the same length. So we can actually say that 4/5 is equivalent to 8/10. I want you to pay close attention to the relationship you're beginning to notice. We'll come to it as we go along in the lesson, but I want you to pay close attention at what you notice, thinking about your times table, what you notice between the fractions that are equivalent, both the numerator and the denominator. What about this one? Well, you would say, okay, they must be equivalent because the length of the bars that have been shaded are of the same length as 4/5, also 8/10. However, it is 12/15. So they are equivalent. What about this one? This is 2/3, right? It's 2/3. We can see that there are two parts shaded out of three. So it's 2/3. But what other equivalent fractions can we find? So equivalent fractions, I just want to repeat. Remember, we're working with trying to find equivalent fractions, simple equivalent fractions. You would have the denominators and the numerator being different, but they are actually equivalent. So if you were to represent them as diagrams, remember our previous lessons where we were able to represent fractions as diagrams, you would notice that they actually are equivalent. So they would have the same size. What would you say about this one? Well, notice that we've now split this shape into 21 small rectangles, out of which this one, which was just 2, we split it into 14 equal rectangles. So actually, this shape is 14 out of 21, which is equivalent to 2/3. Can you find two more equivalent fractions using the same diagrams? Work with your partner or with your parents or anyone you currently watching the video with, or you can try it yourself. Well, we can, because we can get something like this, 4/6, and we can also have 8/12. So these are all equivalent fractions. All right. You can see we have the same sides. Okay. The same size is shaded, but we've just expressed them as different fractions that are equivalent. So we have different numbers, but they are all equivalent. We can have this 12/18 or 16/24. All right, so what you've learned so far, you have learned how to express a particular fraction as a diagram, and you have also learned how to express that diagram as a different diagram, but it has to be an equivalent fraction. Pause the video and answer question 1 in 2 minutes. Assuming you've paused the video and you've answered question 1, here are the answers. Let's discuss them. Here you were asked, so this is showing 3/4. You were asked to use the diagram to work out equivalent fractions. This is clearly 6/8. Okay, so you can see there are 8 rectangles, 8 boxes, out of which 6 are shaded. And here are these. So these are pretty straightforward questions that you could have got right. So celebrate your success. However, if you got it wrong, do not despair. Do not lose hope. Just keep working hard. You'll get better at it. Okay, let's move on. Pause the video and answer question 2. Here you were asked to divide. You're asked to divide the shape to show the equivalent fractions. Okay, so pause the video and answer question 2 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. Here, you could have simply divided it like this. Okay? Now, notice something. What is the relationship between 4 and 12? You don't have to answer. I just want you to think about it. And is that same factor related to 5 and 15? What is the relationship between 4 and 16? Think about your times table. And is that same relationship expressed between 5 and 20? You don't have to answer now. Just think about it. Well, let's do some new learning. Show that 3/8 is equivalent to 9/24 using diagrams. Well, if I give you this diagram, you would say, well, that's 3/8. Yeah, that's all well and good. That's 3/8. What about this one? Yeah, you say, well, that's great. That's 9 out of 24, 9/24. But can we really show equivalence comparing these two diagrams? Obviously not. Yeah, obviously not. But what if we change it? So we say, okay, we know there are 8 rows. What if we have another rectangle that has 8 rows and we try to find equivalence by comparing parts that we can shade to show that the parts we shade will be equal to these parts here? If we do it like this, that may look, well, 3/8. Yeah, we've shaded 3/8, but can we easily spot equivalence? Of course not, we can't. But if we rearrange these rectangles like this, we say, aha, we've actually shaded equal parts, so they are equivalent. So it's important for you to note that sometimes it may be a solution could be rearranging the parts that are shaded in a shape by visualizing what parts of the side of the shapes that are shaded should be placed in what locations, and then you can deduce whether they are equivalent or not. Remember earlier from our first example, we had something like this. What's the relationship between 4 and 8? Think about your times table. And 4, 5th, and 12, 15th. Have a think. Well, you may have noticed this. 4 times 2 gives us 8. And if we multiply the denominator, which is 5, by 2, we'll get 10. Another way of thinking about it is this one. 4 times 3 is 12. And 5 times 3 is also 15. We could think about it the other way around. So we could say, well, can't we divide 12 by 4? Of course we can. And that gives us the relationship between 4/5 and 12/15 is a factor of 3. Now, looking at 8/10 and 12/15, it's not obvious that they're equivalent because you think, but there is no whole number that I can actually use to multiply 8 to get 12. Well, remember when we did this exercise, we found out the factor that links them together. So you could think about multiplying this way to get the larger number, or divide this way to get that number. So another way of thinking about this is to say, what if I divide 12 by 8? Would it give me any special number that I would know about? And what if I divide 15 by 10? Well, you spot really quickly that that number is 1.5. So if you multiply 8 by 1.5, you get 12. And if you multiply 10 by 1.5, you get 15. If you divide 12 by 8, you will get 1.5. And if you divide 15 by 10, you'll get 1.5. So this is what I was telling you about, that pay close attention to the factors that links equivalent fractions. It's a very important skill, or something really important you need to know. All right, let's look at one more example. Is it possible to show that 1/3 of this shape is shaded? How would you go about it? Have a think. Well, looking at it, we cannot quickly say whether they are, 1/3 of the shape is shaded, because the shapes are of different sizes. But if we decide to make all the parts equal, then we can quickly spot whether 1/3 of the shape is shaded. So if we do this, yeah, so if we make them all of the same size, which is that size highlighted in red, then we can draw lines like that. Now we can quickly count to say, well, we have 24 little rectangles, of which 8 are shaded. So 1/3 is actually shaded. Now remember, 8 and 24 are in the 8 times table. So if we divide 8 by 8, we'll get 1. And if we divide 24 by 8, we'll get 3. All right, it's now time for you to have a practice with the other questions in this lesson. Pause the video and answer question 3 in a minute. Assuming you've paused the video and answered question 3, here are the answers. Let's discuss them. You were asked to use a drawing to show that 2/3 is equivalent to 6/9. So what you could have done is draw a diagram just as you've seen here, and then show their equivalence. Okay. Here, same, use a diagram to show that 5/10 is equal to a half. So you can see they are same size of parts, but this has just been made, okay? This has been made 5 times more of this. So you've split this into 5 parts. It's the same part, not 5 times more. It's been split into 5 equal parts. Same size, but it's been split into 5 equal parts. Pause the video and answer question 4 in 2 minutes. All right, assuming you've paused the video and worked through question 4, here are the answers. Let's discuss them. Here, Philip and Esther are writing fractions equivalent to a quarter, 1/4. A. Explain the method that Philip has used to find equivalent fractions. Well, Philip have doubled the numerator and denominator. That's why his numbers are like this. And then Esther have multiplied the numerator and denominator by half. Okay. And so by doing that, you get consecutive numbers 2, 3, 4. Okay. Is that half? Let's see. Yes. It's a quarter. I think it's a quarter. All right. Question 5. Pause the video and answer question 5 in, you can do it in 3 minutes. Okay, assuming you've paused the video and answered question 5, here are the answers. So all these fractions are equivalent to 2/5. You're asked to complete the fractions. So remember what I said, you need to spot the relationship, the factor that links the fraction to other equivalent fractions. Here you can see it's a factor of 2. So you could multiply by 2. Here is a factor of 3. So you multiply that by 3. Here is a factor of 4. You multiply that by 4, so on and so forth. Okay? All right, next one. Discuss with a partner how many fractions are equivalent to 2/5. Of course, there are many fractions that you can create that are equivalent to 2/5. And then here you ask, write 5 fractions that are equivalent to 60 over 70. All right, 6/7 is the first one. You can simply divide this by 10. All right, and there are other fractions. You can have it, which is this one. Okay, so I hope you got these right and you celebrate your success. So well done. Okay, pause the video and answer question 6 in 2 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. Let's discuss them. Here, a shape is made up of squares and rectangles. Show that half of the shape is shaded. So this is almost like the example we did in this lesson. So you're going to have to make all parts of the shape equal sizes so that you can then count and see whether half is shaded. So you can see that everything is 18 when you decide to split them into equal parts. Okay, and when you rearrange them, you see that we've actually shaded a half. Okay, because we have 9 out of 18. These are actually equal. So the shape is like this because of the way I expanded the slide when I was preparing the slide. So they're actually, when you cut them up, they're actually equal. Yeah. Okay. So question 7. Pause the video and answer question 7 in 2 minutes. Assuming you've paused the video and you've answered question 7, here are the answers. Let's discuss them. Question 7, you were asked, Eva, Jack, and Dora have some counters. Eva gives 12 counters to her teacher. The rest of the children give the same fraction of their counters to their teacher. How many counters do Jack and Eva each give their teacher? Well, to be able to do this, we're going to have to do some working out, right? Okay, so let me get my pen. All right. So Eva gives 12 counters to her teacher. So Eva had 18 counters. If she gave 12, her fraction which she gave is 12 out of 18. So they're asking us, the rest of the children give the same fraction of their counters to their teacher. Right. So if this is 18 and then this has to be 36 and it has to be the same fraction of their counters that is given to their teacher, the relationship between 18 and 36 is 2. So Jack should have given 24. Yeah, because if we know that the factor for the denominator is 2, the factor for the numerator has to be the same. So that's why we have 24 counters. And then Dora is 48. Okay. The relationship between 18 and 48 will be so that will be so the way to do it, we can do 48 divided by 18 to find the factor. So we can do 48 divided by 18 to find what the factor is. So 18 divided by 6 is 3. 48 divided by 6 is 8. Okay, so 8 thirds. So it means If we multiply the numerator by 8/3, the denominator by 8/3, we'll get 48. So if we multiply 12 by 8/3, so 12 times 8/3, okay? So if we divide 3 by 3, 1, 12 by 3 will be 4, 4 times 8 will be 32, okay? All right. So I hope you learned from that solution. If you didn't get it right, you can review the solution that I provided. Okay, pause the video and answer question 8 in 1 minute. Assuming you've paused the video and answered question 8, here are the answers. Let's discuss them. Here you were asked, find the missing numbers to complete the comparisons. Okay, so we can see that so the answer is, so what could each missing number be? What numbers would not work? So the missing numbers could be 4, all right? Could be less than or equal to 4, and it could be greater than or equal to 20, all right? For this comparison to be okay. And they are all possible values. So there are many numbers that it could be. Yeah. So it could be, any numbers within these values. Okay. So you can try the numbers to test it out to see that it's actually correct. All right. That brings us to the end of the lesson. So what have we learned so far? We have learned that you can use equivalent fractions you can use the method. So after using diagrams, you no longer really need to use diagrams. You can simply think about your times table and think about the factor that links the numerators of your equivalent fractions and the denominators. Now, remember, the factor does not only have to be a whole number. The factor can be a decimal number. So it could be a decimal number and it will still work, provided you've got the factors right for both the numerator and the denominator. Until next time, thank you and well done for learning. Take care and bye-bye.